I've been trying to record this on live stream, but the flicker rate, the frame rate of the live stream is causing me a lot of problems. So I've got the lights turned out so that I can record this for YouTube. But basically, a new circuit I've been working on is a pulse drive circuit, and it's to drive my bubbleator device, my magnetic motor. Well, I need MOSFET drivers, and I need a 1 millisecond pulse to trigger the Alnico magnets, which actually bias and polarize the flux on the neodymium magnets. Well, at the moment, I've got this running at a slow speed, so that we can see the pulse rate. Because if I speed it up too much, it's actually about the right speed actually at the moment. But the green LED, this one, is basically showing the output from the MOSFET. So I'm just doing a test run with one MOSFET. There's actually two MOSFETs on the main circuit board, which basically is I'll put the light on a minute. This one is one I built the other day, but there was a problem with the circuit, and I had some issues with the actual driver circuit. So I've taken the chip out of here right now. It's just got the voltage tripler circuit, which is still in there, which is driven by a 555 timer, which drives these two MOSFETs, which generates 60 volts on the output to this capacitor, and the 60 volts is what provides the voltage for the pulse drive, which is these other two MOSFETs, which are IRF634s. I think that's right, IRF634s. Anyway, this part of the circuit, the IRF634 section, not working properly. I've got opto isolators in there to drive the MOSFETs, and the opto isolators are driven by this TL494 chip, which I've taken out for the moment. I've actually got one here in my breadboard. So anyway, basically I've got to make another one of these because of interference. I was getting a lot of interference, so I stuck a capacitor across the PMOS and the NMOS MOSFETs to try to sort the problem out, but that didn't seem to. Well, it helped a bit, but it didn't work very well. So the new design has got, I've built some chokes in to the actual circuit. You can't see the LEDs very well with the light on. That's the reason why I turn the lights off. Anyway, the actual output on the oscilloscope is basically about 1 millisecond. That's the pulse width. Well, I've actually got it set a bit high at the moment because I've been experimenting, but that's my pulse there. And that's for driving the MOSFET. And the pulse, peak to peak on the pulse at the moment is it's about 15.5 volts peak to peak. It's hovering in between 15.4 and 15.6. So, and the mean voltage 600 millivolt. I'm running at 14.14 hertz, which is very slow. I want it running slow actually. I want to keep the frequency down because we have dead time basically between the pulses. If you notice, there's a huge gap between each pulse, and it's the gap that is called dead time. And the dead time is what I want because that is the freewheeling mode when we flip Alnico polarization. The flip Alnico magnets, we change the polarization. And the idea is that the Alnicos will do some of the work for the generator. And at the moment, I've got some Alnicos in this coil, and I've been flipping the coil with the electro pulse to flip the polarization. Can't show that right this minute because I haven't got my high voltage parts running, but anyway, I'm pretty sure I've shown that in previous videos. So anyway, that's just a little YouTube update on what I'm doing at the moment. I haven't made any videos on YouTube lately. I've been doing some live streaming, but to be honest with you, YouTube videos, they do take up a lot of time Oh, what's happened? Oops. I pulled my green LED out. Oops. How did that happen? Must have knocked the... what are we doing? Where are we? I've got this right way around. This is what happens when you lean over and you catch things. There we go, it's back on again. Yeah, my probe is connected, my oscilloscope probe is actually connected to the LED, so I knocked the probe and it pulled the LED out of the experimental board. Anyway, so that's basically what I'm doing at the moment. I can actually slow the speed down a lot more if I add this capacitor to the circuit. Now I can't see which is negative now. That's negative. So if I put this capacitor in, then it should slow right down, and we can see that there's a big gap between the pulses, which is called the dead time. But even the frame rate on this camera seems to miss a beat every now and then. It's in between frames, there's the LED flashes and the camera misses it because it's literally a millisecond or just under a millisecond. These pulses are a bit longer than a millisecond. I think I can't really see actually. I think it's 26 milliseconds. So these pulses are of a duration of 26 milliseconds, thereabouts. I'll take this out again and it should speed up. Yep. Anyway, thanks for watching.